So as a recap, I'm just recapping what we have done today for the video. So we started today with extracting the code from item identifier. We have done the first process, which is the extraction of item code from item identifier using the lambda function. Then we found out there are three categories: food, non-consumables, and drinks. Then we printed fat contents and we found there are duplicate levels, LF and low fat and reg for regular. We have replaced them. Then we have calculated outlet age from outlet establishment year as of 2021. Outlet age is a new column. Then we have printed the columns, including the new columns, item out code and outlet age at the end. And then we separate the data into numeric columns and object columns. We have separated the data into numeric columns and object columns. This is what we have done today. Once you are done, please confirm. I'll go to the next step. Pardon? Okay, no problem. Take your time. Now, why do we need to split them into numeric and object columns? Why do we need to split them into numeric and object columns? Because we need to dummy encode object columns. Object columns are in text, right? You cannot have text in the data. You have to dummy encode. Dummy encode means assigning the numerical identifier to the text column. Take for example, your gender. Male, female, male, female, female, male, and male. You have the gender like this. You can't have the text. So you have to dummy encode. Dummy encoding means assigning numerical identifiers to the values. In Python, alphabetical order and starts from 0. The assignment of numbers will start from 0. So we have a process called label encode. Label encoder. Label encoder. Label encoder is a function which is available in Python that assigns numerical identifiers to text data. Alphabetical order. So M will be given 1, F will be 0, 1, 0, 0, 1, and 1. Because F comes before M. That is why F is given 0. F is given 1, alphabetical order. Now this is one way of encoding. This is one method of encoding. There is one more method called pd.get_dummies. There is another method of encoding called pd.get_dummies. Now this function will create new columns. It will create gender_m and gender_f. Two new columns will be created. And then it starts binary encoding. Binary encoding means no means 0, 1 means yes. So this is 1, 0, 1, 0, 0, 1, and 1. If it is this is 1, this is 0. So this is 0, this is 1, this is 0, this is 1, 1, 0, and 0. This is binary encoding. Here it is binary encoding. This is binary encoding. No is 0, yes is 1. This is label encoding. This is different. Now the biggest difference is label encoding will do it in the same column. It will not add columns. Whereas get dummies will add columns. As long as you have enough data and you are okay with adding new columns, run get dummies. Particularly in regression. If it is a regression problem, always use get dummies. If it is classification problem, you can use label encoding. Okay? When you are dealing with regression problems, binary encoded new variables creation is best suggested. Marginal difference in answer will come, not big difference. But if you don't have enough data, then you can also run the regression problem label encoder. If the decision depends on the amount of data you have. What is the definition? 20 observations per variable. This is the minimum sample size per regression. For regression, the minimum sample size is 20 observations per variable. What is for classification? 50 observations per variable is the minimum sample size. Right? As long as you have data and you are okay with creating enough columns, go with get dummies. If you don't have enough data, then do the label encoding in the same column. Get dummies will create new columns and use binary encoding 0 and 1. Here you will go 0 to n levels. Label encoding 0 to n levels based on the number of levels in the category. And it is alphabetical order. Alphabetical order. Not based on frequency. It is based on alphabetical order.
The regression frequency classification
50 observations minimum. Now, I think we have enough data here. We can run get dummies. So, object columns dummy is equal to pd.get_dummies object columns comma columns is equal to, you have to give this list. Column is equal to, you have to give this list. Control C, Control V, paste the list down. If you don't give the column list, it will not do the encoding. And you have to adjust the indentation also. So object columns, comma, you copy paste the object column list, you'll get the data. Now, object columns dummy dot shape. See, you have got 42 columns. You got 42 columns. Actually, how many columns are there? 1, 2, 3, 4, 5, 6, and 7. It created 35 new columns, right? You can see the list also. Object calls dummy dot head 3 rows. Item fat content low fat, item fat content regular. 2 columns it created. Item type for different products, baking goods, breads, it created new columns, right? And in the end, you can see here item code DR, FD, and NC. 3 new columns are created. So get dummies will create new columns in your data and uses binary encoding for doing this. Label encoding will do exactly in the same columns, 0 to n levels. Whatever is levels is there, it will do it in the same column. No addition of columns is done in label encoding. In regression, get dummies is preferred. Big mark cells is what problem? It's a regression problem. You got the file? Please call me. You run all these things, right? Not like this. You got the notebook? Download, where did you the notebook, right? Download, where did you save it? By default is downloads, right? All you have to do is double click this. That's all. Then you have to go to the path you have. You can directly do this commands. And as long as the stars are there, it is running. Stars means it is running. And once it becomes a number, then it's done. We can even type the numeric columns or object columns. Numeric columns I will show you. Yeah. Here, first print the columns and then copy paste the numeric columns. Double square brackets combined here. Now check whether the stars from stars are still running. What? Right to go. No, scroll up. Where it got stuck. No, it's polygram. Those the government will take them. Just give 2 minutes. Everything is smaller. Yes. Now, both there is an error. No. Here we have imported the test data. To change the test data file path. Now we pasted that. 1 second. Do one thing. The same path. Then test data is also in the same folder. Right. When you change the name of the file, no, you have changed the name of the file in the folder. Test underscore name. This you can go with the numeric column or with first. Dot here. We'll go ahead. But please don't accept all of your many errors. Or I'm happy to take it from your level. You get started or doesn't.
Sir, Ttest underscore XLX,
Dot XLX.
read underscore
EXCL. Excel.
X.
Read underscore EXCL. So this is dummy encoding of the object columns. PD.get dummies. Copy the list. You'll get the dummy codes. That is not a special, that is not a notes. That's the proper. XLS. Yes. Actually, I am 5 XLS. He opens with Excel option and file structure is CSV only. So you should not use Excel text. You have to use CSV only. So read underscore CSV. This is also desktop లో లేదు కదా ఇంకో ఫోల్డర్ క్రియేట్ చేయాలి కదా అప్పుడు నేను ఆర్ ప్రోగ్రామ్ స్పేస్ ఉంది కదా we have created the second folder also. Now it all the other things will run. Okay, dummy encoding, all of you understood, right? Get dummies and label encoder. This is a common interview question. What is the difference between label encoding and get dummies? Get dummies creates new columns and uses binary encoding. Label encoding, same column, 0 to n levels. Now we have label encoded our data. The whole pre-processing is done. Now we will concat into a new data frame. Combine df clean is equal to pd dot concat open bracket numeric calls comma object columns dummy square bracket. Sorry, I forgot square brackets. For column concatenation, access is equal to 1. Column concatenation. Yeah. No, it is an automatic function. It automatically does. le.fit_transform will automatically does. We'll use it on HR analytics. That we will understand. Be careful, this is object columns dummy. We are concatenating. First pasting all the numeric columns, next we are pasting all the object columns dummy. Column concatenation. First, we will paste all the numeric columns. Next, we will automatically paste object columns dummy. Earlier, we did row concatenation. Train rows, test rows. Now it is numeric columns, object columns. First, all columns are numerical. Adjacent to it, all the columns are object columns. Column concatenation. We earlier did row concatenation. Now we are doing column concatenation. Axis is equal to 0 is row concatenation. Axis is equal to 1 is column concatenation. If you are looking for similar commands in R, axis is equal to 0 is R bind. Axis is equal to 1 is C bind, column bind. We use them in the R also, right? Row binding and column binding for the same data. All right. Now we will split the data. We are doing here column wise concatenation. Of numeric columns and object columns. Now we will split our data into train and test. Split data into train and test after pre-processing. Bigmart train DF and changing it as Bigmart train DF is equal to combined DF clean square bracket combined DF clean dot item outlet sales not equal to test. Exclamation equal to is not equal to. Similarly, Bigmart test DF is equal to combined DF clean square bracket combined DF clean dot item outlet sales double equals to test. Not equal to test is your train data, equal to test is your test data. So once we dummy encoded the columns, we concatenated them into one data frame, and then we have split them back into train and based on the outlet sales. Now the one thing is Bigmart test DF is equal to Bigmart test DF dot drop item underscore outlet underscore sales comma axis is equal to 1. We are dropping the item outlet sales from the created to concatenate. That is the C output of dummy dot head. This is creation of dummy. Combined DF clean is this. DF clean is the concatenation of numeric columns and object columns dummy. What are our output? System format changing of data backup చేసుకోవాల్సిన system format చేసుకోండి. Guys, you understand the process, right? Same process you can implement in real-time data science also. First, get the data, understand the head, tail, all the data points, then understand the variables, then do the physical analysis, then include them, then separate the numeric columns, object columns. These are functions. These are small data sets, so they are very manual. There is a function called select underscore details. Select underscore details include only object columns, it will take only object columns. Include number, it will take both 64 and 460. When we deal with larger set of columns, we will be getting through those functions. And if you are confusing about conclusion about the functions we are using, write down on the notebook. Whatever functions we are using, the two functions, write down in the notebook. The function format and the name why we are using. Because as you go ahead in data science, we will be using more and more functions. Programming is least required. You will do a programming session also. Python programming, I will introduce you where we will be doing iterators, loops, class, modules, and there is a session on deployment also. How to deploy it as an application. Web-based application. So all those things will be there. So as you go in, the complexity will rise. So if you are getting it now, write down the function names in a notebook, and whenever you go home, the document is available online. You just type the function name in Google. It will take you directly to the documentation. You can read the function documentation. Okay. Which one? I will implement it. Implement it. Everything will be implemented. I will go ahead and another one. Okay. Now, one last step is there. I want to know the type of Bigma train DF item outlet sales. How will I find the type? Data type of Bigma train DF item outlet sales. We have a type function, right? To find the data type, what is the function? Type. Type Bigma train DF dollar item. Sorry, dot item outlet sales. Oh, it says it's such a D type we have to use. Yeah, data type we have to use. D type is giving you the series dot D type. Type is showing as what? Not zero. It is showing it as object. Because we have added the test words to the column, right? So it changed from number to object. Because remember, the item outlet says 8,520 rows are values, remaining 5,000 rows for the word test, which I have incorporated. So we have to convert it. So Bigma train here dot item outlet sales is equal to Bigma train here dot item outlet sales dot as type float 64 dot as type float 64. So it is giving us a warning that we are doing a major change, but as type float 64. Now, if I run the previous dtype command again, now it changed to float 64. What is the difference between float 64 and int 64? Decimal points. Float 64 and int 64 is a whole number. Since we have added the test object data into item outlet sales, and we are concatenating the data frames. The item outlet sales data has been converted to object. Right? Now we have to convert it back to number, which is float 64. Because see, in the item outlet sales, we have numeric values as well as the word test. 5,000 cells have the word test. 8,520 rows are numbers. Yeah. Down. Hmm? It is pink color is it's warning because you're doing a major change on your data. It gives you a warning. It's not an error. All right, it's 4 o'clock. Let's take a break for 15 minutes and come back. Classes So basically, we have done the data pre-processing as of now. Completed the data pre-processing on Bigmart train data. Whatever we have done in R, we have done it in Python. Same processes have been executed in Python. Now, the same thing what we have done in R after pre-processing, we did the hypothesis testing. So we will do the same hypothesis testing here. Inferential statistics or hypothesis testing. What is hypothesis testing? Comparison of what? Means or averages of two or more than two groups or levels or classes. Different textbooks use different words, but it is comparison of means or averages of two groups or levels or classes. Today, I think some of you got confused with the hypothesis test questioning, right? So you have to have the conceptual clarity very easily. One numeric variable, other categorical variable with exactly two levels. With exactly two levels. We have to do what? We have to do two sample independent t-test. One numeric variable, the other categorical with exactly two. In the question, what hypothesis test you will do if there is salary and gender? Gender will have only two as of now. The third category will be added later, LGBT or whatever it is. But as of now in India, we have only two genders, male and female. What test we will do on gender? T-test. Two sample independent T-test. Blindly. Gender, two levels, two sample independent T-test. More than two levels, education. You will do ANOVA, single factor or one-way ANOVA. So one numeric variable, one numerical, other categorical. Other variable is categorical with more than two levels. What we will do? We will do ANOVA single factor or also called as one-way ANOVA. One-way ANOVA. Remember these tests. These are common tests which you will be doing when you go to industry. Hypothesis testing has to be done to validate an argument. Suppose your manager and you are disagreeing. Average sales by male customers is 58,000. Average sales for female customer is 56,000. Your manager is saying 2,000 is not a big difference. But you are arguing, no, that 2,000 is a significant difference. It depends on the variance and the number of observations also, right? And then you will do a t-test and tell him, see, the t-test is saying the 2,000 rupees difference between male customers and female customer sales is a significant difference. We can't treat them as equal. So that sort of things will be constantly questioned. Whenever you have a question, you frame a hypothesis, run the relevant test, and then you will get the test validated. Close of argument, that's all. So, and then these are the numerical and categorical tests. If both are categorical, both variables are non-numerical and categorical. Yes, non-numerical and categorical, we have the chi-square test of independence. And if both variables are numerical, what will you do? Both variables are numerical. What are the measures of relationship? No. Covariance and correlation. So forget these things, right? What does correlation tell you? Relationship between two numeric variables, right? Quantification. Covariance will say whether both of them are moving in the same direction or opposite direction. Now, you have said paired sample t-test, right? Paired sample or dependent sample t-test. This is done when your data is in the form of before and after. Blood pressure of the patient before taking the tablet, blood pressure of the same patient after taking the tablet. There, one person is giving you two data points at two time intervals. That we call it as paired sample t-test. Paired sample or dependent sample t-test, the data will be in the form of before and after. Before launching a marketing campaign, what was the sales? Digital marketing, we do this. You know, Facebook ads and all, short term. Facebook ads are not for long term. They are run for a very, very short term. Facebook ads, your WhatsApp ads all run for number of days. So what were the sales 30 days before running the Facebook ads? What was the sales 30 days after running the Facebook ads? Whether the sales has increased or decreased. Then we find the difference, and is the difference is significant or not, the test will tell you. So paid sample t-test is the common test we do in digital marketing to argue with the client that your campaign is successful. Client will obviously say, no, the sales did not increase that much. But it's the digital marketing guy's job to prove that the difference in sales is statistically significant or not. He will say, what were your daily sales before the ad? What were your daily sales during the ad? The same time period. Take them. Run the test. The test will tell you whether the sales has increased or not. So in digital marketing, when the campaign is done by a third-party provider, they do this test and send the output to the client also. Say, these were your the sales earlier. This is the sales now reported by your listing. Or earlier, this many visitors were going to your website. Because of our campaign, this many visitors came to your website. To prove the success of the campaign, you have to do a test, validation test. We call it as validation test. Or in what we call web design, A/B testing. A/B testing is also similar to this. A/B testing means you will develop two sets of graphical pages. You are changing the web design. Which design to be implemented, you are not sure. So you will put 3 designs for some period of time, and you take the feedback from your customers, and you run it A/B testing test, and then it will tell you which is good, and accordingly you will finalize your web design. A/B testing is also a paid sample t-test. A/B testing is also paid sample t-test. So A/B testing is widely done for web designs, product designs. Your what you call design theory is there, innovative design thinking and design theory. A/B test is done. Okay, so we will do first we will do 2 sample independent t-test. We have only one variable here which has 2 levels, which is the item fat content. We have only one variable that has 2 levels in this data, which is item fat content. Only one variable with exactly 2 levels. With exactly 2 levels is your item underscore fat underscore content. Okay. But we have already done the get dummies, right? So we can't do the test here. We have done get dummies and we have separated the data into 2 columns, 0 and 1. Let us see Bigmart train dot item outlet sales dot group by Bigmart train dot item fat content dot mean. See, we have, it's not 2 levels. It has more than 2 levels. No? The original data we did not clean. Bigmart train data we have not cleaned. Right? So that is why it is showing as multi-levels. See, low fat, low, and all these things. Right. So what we will do is, for the time being, we'll correct the data. But which one is clean? Combined DF is clean. Huh? Combined DF. But item outlet sales will not be numeric there. That is a problem. Or let us clean only one variable. Na? We'll clean it here only, Bigmart train. We also can practice Bigmart train dot item fat content is equal to big mart train dot item fat content dot replace open bracket square bracket single quote LF comma low fat, replace it with low fat. And then big mart train dot item fat content is equal to big mart train dot item fat content dot replace reg with regular. Okay. Now, if you do the group by, we'll get only, sorry, big mart train, we'll get only 2 levels. So only small thing you have to do, only 2 lines. Run the item fat content, replacement, low fat and LF, and big mart train dot item fat content, replace reg with regular. So you're correcting the levels in the big mart train. So that we can have exactly 2 levels. If you want to find variance also different, what should I do? If you want to find the variance also, whether the variance is different or not, what should I do? I'll replace mean with variance, right? If you just replace mean with variance, you'll get whether the variance is also different or not. Find out if the variance is also different or not. So just simply focus on the content, syntax and functions. I will share the notes with you. So please don't bother to write or use a pen and paper. I will share the notes with you, the PDF file as well as the IPNB file. For all your exams and evaluation, just go through the PDF files which I am sending, where you have all the short notes, right? If there is a PDF file in your mail attachment, that means notes is there in that attachment. Simplified, summarized notes. And all of this start working on your GitHub profiles also. GitHub projects. HR analytics, I would suggest a good project. Exploratory data analysis, use your creativity, or whatever questions I've given, right? They're all exploratory data analysis only. For all those average and that, you create a bar plot also. Make it as neat as possible, EDA. Okay, so one regression project, one classification project, one time series project, one natural language processing project, and one deep learning project. 5 projects should be there in your GitHub profile. The target is we will be sitting into placements most probably middle of April. Already there are people ready to recruit. The only thing is we have to be ready. Wipro, Capgemini, they are desperately wanting people. So my target is freshers, they're offering 3.2 to 3.8, depending upon their engineering scores and all those things. For experienced guys, based on your work experience, that's a different recruitment they are doing. Freshers they are doing now. For experienced guys, they said they'll come back. And 20% existing pay they will give you if it is same city. If it is for Pune or Bombay, accordingly they will give you the package. Wipro also, freshers they offered some people 4, some people 4.8. One person who had work experience with SQL, he was offered 9 lakhs. So SQL also is required. So if you have any idea, your SQL training is done. Not done. SQL done. But not that. You have to go deeper. Not the simple create and all. You have to go into deeper SQL questions. Because in MCQ test, whichever is being given by recruiters, half of the questions are from SQL only. MCQ test means half of the questions will come from SQL. Then all of you got this correction. Now we have low fat and regular fat. Average item outlet sales is different. What is the fundamental assumption of hypothesis testing? The means must be different. Then only you will conduct the hypothesis test. The fundamental assumption is means must be different. If means are equal, you should not conduct this test. Now, means are different and exactly 2 levels. So this is a right case for 2 sample t-test. Now, in R, we can do using the tilde and the formula, but Python is lazy. That means we have to manually split the data into low fat and regular fat, and then we have to calculate the respective averages, variances, and then do the test. Okay. Manually, you have to separate the data here. In R, it was doing automatically in the backend using the tilde. The only thing is there is a test function. For function test, there is a function, but you have to manually separate the data. Okay. So let us separate the data first. Separate or split data into low fat and regular. Be careful with the names. So LF is equal to Big Mart train, square bracket, Big Mart train, dot item fat content, double equals to single quote, low fat. If you have any doubt, you can copy paste from the top. Copy from here. If you want, you can do the Control C, Control F from there. And then reg. Reg is equal to Big Mart train, the data frame reference, square bracket, the column reference. Data frame reference, square bracket, the column reference. Big Mart train dot item fat content. And when you're using is equal to as logical operator, you have to give it as 2 times. Single quote or double quotes, your choice. Regular. The name should exactly match. Now we have split the data into 2 data frames, LF data frame and regular data frame. LF data frame and regular data frame have been split. And what is the null hypothesis? No significant difference in average, the numeric variable. What is the numeric variable? Item underscore outlet underscore sales of the categorical variable. Different item fat content. All you have to do is change the name of the numeric variable and change the name of categorical variable. Rest of the statement is same. See, this is changed based on the numeric variable, different, and then you change the categorical variable name. That's all, simple. Now, what is the difference between null and alternate hypothesis? The word no before significant. Copy paste it down. Remove the word null to all and remove the word no. That means significant difference. No significant difference, significant difference. No significant difference means you can treat both of them as equal. Significant difference means you cannot treat them as equal. Right? Significant difference. No significant difference is null hypothesis. Significant difference is alternate hypothesis. The word no is the only difference. Otherwise, it's all same. Now, from scipy.stats, like when I was introducing you the Python folder packages, I told you, scipy.stats is part of NumPy. This is for statistics. From scipy.stats, import Ttest why it is not working underscore int. Now it is coming. See, go to Google, type scipy.stats. You'll get the documentation page. Scipy.stats, statistical functions for Python. Control F. Control F. What we are doing? Independent. See, it is directly going to the function. Calculate the t-test for means of two independent samples of scores. Click on this function name. See, what is the null hypothesis? Independent samples have identical average or same average or no difference in average. It's there automatically. That two independent samples have identical average or no significant difference in average, which means they are identical. They are same. They can be treated as equal. So you don't need to remember. The documentation is very clear. T-test underscore in. You can see the what is the unit AB, and this is the argument you need to remember. You have to give equal underscore var is equal to false. Because you check the variance also, right? Variance is different or same? Variance is different, right? Variance is different. So we have to give equal underscore var as false. See, equal variances is a hypothetical situation. Very rarely it happens. But the equal variance will not happen. Here, I think you can check it. The variance is also 2.8 and 2.9. So it is different. So equal underscore var is equal to false. So the documentation is pretty much clear. If you get any doubt, type the function name. You'll get the reference and you'll also get the example, how to run a detailed example. Everything is given in the documentation page. Okay. Because remembering is difficult, I know. So at least you should know where to look for. So Ttest underscore ind lf dot item outlet sales comma reg dot item outlet sales comma equal underscore var is equal to false. Equal underscore variance. Now, if you are not sure, you can just check the variance also. I'm just replacing mean with var. 2.88 and 2.963, they are completely different. So equal underscore var is also false. Now you got the p-value. If you look at the R, you might have got the same exact p-value. Since p-value is greater than 0.05, what should we do? If the p-value is greater than 0.05, fail to reject null, which is nothing but accept null. But we can't use the word accept. That means, what is the null hypothesis? No difference in averages. That means we can treat both the averages as identical or equal. We can treat both the averages as identical or equal. Got it? You remember the formula? What is the formula? Mean 1 minus mean 2 divided by square root of variance 1 by n1 plus variance 2 by n2. The t-statistic formula. Is equal to, the numerator is mean 1 minus mean 2 divided by SQRT, square root of 2 brackets, where 1 by n1, number of observations of 1, plus where 2 divided by n2. Variance of 1 by n1 plus variance of where 2 by n2. Which one? Practice. 2 cycles or 2 datasets. If you are doing it seriously without other aggregations like TV, Facebook, WhatsApp, you will get it. Right? Without any other aggregations, if you seriously take a dataset and run these things manually, looking at it, not cut copying, typing and understanding 2 hours or 1 hour a day, or in a week 4 hours. You split it, that's all. Rest of the time you don't even need to look at it. You will get the practice. On 2-3 datasets, if you run, this becomes familiarized, right? Yes, you have to check. Yes, I will give. We will practice after the test. We will do all the HR analytics also today. I will give you the null hypothesis. You will be doing the same test. For only talk, you get both. So sometimes you have to do, right? Doing is better than talking. All of you got this? Now, I want you to guys to test null. Test null, the average item underscore visibility of low fat and regular are equal. Test null, the average item visibility of low fat and regular are equal. So what you have to do first? Group by mean, then group by variance, copy paste the same command and change it. Group by var, then null and alternate. The data is already split, so you don't need to split. Data is already split. So conduct test and interpret, infer. Do the group by item visibility. Average item visibility of low fat and regular are equal. It not change. Decimal difference. Marginal decimal difference. Right? What was the output there? Marginal difference or the smallest difference is also big difference. Don't use here. Here is get them instead. What is the calculator? So P value is less than 0.05, we will reject null. What is the null? No significant difference in average item underscore visibility of different item fat content. So this is the process. First find the group by mean, group by var. Then we conducted the test and we got the p value less than 0.05. Calculate the forward working strategy. You have all the data now. You should get this. Right? We have the mean, right? What is the mean? Right? This is the mean, right? 0.060, control C, control V minus mean 2, 0.069, right? Divided by np dot sqrt. NumPy has the function called square root. np dot sqrt variance 1 divided by how many are low fat? We have combined DF now. Okay, okay. We don't have here in the count. Okay. No, that table you can do, no? Sigma train dot item fat content dot value underscore counts 5517. This is double 5517 plus open bracket. What is the other? 0.02726 divided by 3006. Get minus 4360. Not exactly same, right? Some decimal marginal error will be there, but we will get the same value. Just about determine on the T distribution. Degrees of freedom and T distribution. Students T distribution table will be there. So in scipy.stats, go back to the documentation. Control F, T dist, or let us say distribution. Probability distribution, continuous distribution, alpha, beta, chi, exon, kappa, norm, multivariate, ambidextrous, Poisson distribution, Anderson distribution, normal, one and pass, certain distance. Actually, we don't have the function here, but in Excel we have T-dist. In Excel, we have a function called T-dist, right? If you give this statistic value and then degrees of freedom, n1 plus n2 minus 2, it will give you the p-value. A T distribution table will be there. Students T distribution table. Students T distribution table. So you can see these tables will be given. Here we have to look at the T calculated and P1. This is one tail. We do two tail, right? This is two tail. This is also one tail. We need two tail. This is two tail. No. Okay. This is two tail. So two tail alpha 0.05. So here we go with the degrees of freedom. Large Z, it is 1.960. 1.960. T calculated, ignore the minus sign. How much T calculated we got? 4.34. 4.34 is greater than 1.960, which means reject null hypothesis. T calculated greater than T table, reject null hypothesis. Or P value. You can do two base inferences. Like here we see the T calculated for large Z. 1.960. 1.960 is 210, 0.05. Right? 0.05 means how much? 95% confidence level. Largest C, because they have more than 30 observations, right? So 1.960. What is our calculated value? If you ignore the mathematical sign, you ignore the mathematical sign. In T statistic, we don't take care of the mathematical sign. So 4.34 is greater than 1.96. We reject the null hypothesis. If T table is Sorry, T calculated is less than T table, fail to reject null. That is how we do. But distribution probability is a little bit formula is different. There are calculators available online. You can use them. Okay. So T-test you understood, right? SciPy.test, T-test underscore in. Now, test null, the average item underscore outlet underscore sales for different outlet underscore type equal. So first find out how many types of outlet are there. Do the group by function and find out how many types of outlet are there. How many outlet types are? So Bigmart train dot item outlet sales dot group by Bigmart train dot outlet type dot mean. We have four: grocery store, ST1, ST2, and ST3. Now you have to split the data into four data frames. GS is equal to Bigmart train square bracket Bigmart train dot outlet type double equals to, copy from here. Don't take a risk. Copy the Control C, double quotes, Control V. Similarly, ST1 can copy the command down, Control C, Control V. Instead of grocery store, replace it with supermarket type 1. Control V. ST2 is equal to, you can just copy the whole command, paste it, type 1 will become type 2, ST3, paste it, and type 1 will become type 3. Copy paste the arguments, you will get the these exactly match will get any. Once you do the test, you get any. Those things doesn't match. From scipy.stats import f underscore one way. ANOVA is f distribution. ANOVA is f distribution. So we are doing one way ANOVA. F underscore one way. Same f underscore one way gs dot item sales, comma st1 dot item sales, comma st2 dot item sales, st3 comma all four separate comma. F underscore one way. GS dot item outlet sales, comma SP1 dot item outlet sales, comma SP2 dot item outlet sales, comma SP3 dot item outlet sales. So we got p value as what is the null hypothesis? Same statement. No significant difference in average item underscore outlet underscore sales of different outlet types. Of different outlet types. No significant difference. Test null, the average item underscore MRP of different outlet underscore type equal. Item MRP of different outlet type. We have already split outlet type, so average item MRP. Different outlet 140, 141, 141, and 139. F underscore one way, GS dot item MRP, comma, ST1 dot item MRP, comma, ST2 dot item MRP, comma, ST3 dot item MRP. So we got p value greater than 0.88. Is greater than 0.05. What we will do? Fail to reject null. That means we can treat these averages as equal. You can treat these averages as equal. But numerically, they are not equal. Statistically, the difference is insignificant. Statistically, the difference in means is insignificant. If you want to talk difference in means is statistically insignificant. The right word is insignificant. If it is reject null, statistically significant. So today's question was level of significance, right? Some of you made error there also. Hypothesis test is all about level of significance. And most of the questions which I have given you, except 3, all conducted by MCQ tests by companies. Only 3 or 4 questions which I gave. The rest of all gathered from the MCQ tests attended by our other batch students, PGS students for different companies. So most of the questions will be like that. But nowadays, half of them are SQL. So practice your SQL whenever you get time. One second. WhatsApp is there, right? I'll show you the sample question. Let me email it to me. Oh, it's in my email only. Sorry. This is last week jobathon done by this guy got into Capgemini. He's working in Spark. This is a doc scanner. See here. Which of the following is correct command to restore a database from players.sql to a new database, legends in MySQL? You wrote unroot, P, player SQL, MySQL. So you have to restore a database from player SQL to new database, legends. So that's what. I told you now, advanced SQL, they're asking. That's a big change. Look at this. This is even more bigger. They have given recipes 3 files. You have to find which of them will give you the correct answer. Select recipe title from recipes, where recipe ID in select recipe ID. From recipe ingredients, where recipe ingredients in select ingredient. From ingredients, inner join ingredients items where seafood. So like that, they gave 4 options, A, B, C, D. This is one option. Like this, they got 5 options. Only thing is, in B, instead of inner join, they have used outer join. In C, instead of they use left join. In D, they use right join. Now you have to decode this whole SQL. This is one option. So that's what I'm telling you. This is done by last week only. Maximum scored by our guys was 23. 30.
Would you mind sending us a document, sir?
Yeah, I'll share. We'll work on these, all these things. Interview questions, everything will be shared with you. See the length of the query you see here. I believe you never have done this much of big query, right? Here there might give you one line, select, create, where, that's all. But here see, look at the complexity of the query. So that is what is happening. So they are, because there are too many people, right? Writing tests. So they have to give complex tasks. See here. What is the meaning of like person zero in SQL? So what is the option? Correct option. Any position. D. If they give 1 minute 30 seconds for each question, same timing what I gave you. So 1 minute 30 seconds for each question. See here. So consider the following table. So select the correct query to print the first name and the final price after subtracting the discount from the base price in that order. So no longer simple SQLs they are giving very complex things. And most of the filtration is happening on SQLs only, which we take for granted. We take lightly now. SQL, what is there? SQL, it's very easy. But when reality comes, the simplest thing only will cause you the most problem.
First name, final price equal to clause and then
Actually, they found that B is correct. But I am not sure. B is correct. See, consider a database with following tables. Again, very lengthy queries, 4 of them they have given. So 50 questions came from SQL only, out of 30. 10 questions from machine learning, 5 questions from statistics. Machine learning means bagging, boosting, decision tree, entropy, Gini, like that. But this is the type of questions you will see in SQL also.
now we are dealing with machine learning.
No, we have not started machine learning. We are in inferential statistics. Machine learning means we will start with that one. We'll start with MLR first. Then we go into logistics. Then we go into trees. Single tree model, multi-tree models. Then we go to neural networks, support vectors, k-nearest, everything will be covered. So that will be models where theory will be discussed in detail and then the practical. Okay. So on HR analytics, if you want to try at home, you can try is underscore promoted and length of service. HR analytics, now you can write down the questions if you want because we are already reached time. Or you can open the HR analytics. I'll paste the questions here only. Yeah, I'll send you the document. Both. So here, if you want to do the test, test null, the average length underscore of underscore service of is underscore promoted equal. Is underscore promoted is binary. You can also do test null, the average length, or sorry, average AVG underscore training underscore score of male and female equal. These are your what you call Ttest. Test null, the average length underscore of underscore service of recruitment channel, different recruitment underscore channel equal. Similarly, test null, the average underscore training underscore score of different education equal. So you can do this one-way test and the t-test. And chi-square is left out now. It's very easy, simple chi-square test we will do. Oh, sorry. I'll mail the questions. Don't worry. I'll mail the questions. PD dot cross tab Bigma train dot outlet type comma Bigma train dot outlet location type PD cross tab. So this is the cross tabulation. Cross tabulation of outlet type and outlet location type. Both are categorical, right? Test null, no association or relationship between both variables. Test null, no association between both variables. What are the both variables? These two, outlet type and outlet location type. Like in R also, here also the input is cross tabulation. The input is cross tabulation. From scipy.stats import chi2 underscore contingency. Chi2 underscore contingency is the function for chi-square test of independence. And then you paste the PD dot cross tab function inside. This is the p-value. This is the p-value. This is the chi-statistic. Observed minus expected whole square divided by expected sigma. This will get, and this is the p-value. Degrees of freedom is number of rows minus 1 multiplied by number of columns minus 1. I showed you in Excel, right? Last time. So this is the no association between outlet type and outlet location type. Chi-square test of independence. Chi2 underscore contingency. And remember, first three letters and press tab. First three letters and press the tab, autofilling will come. Three letters and tab. Three letters and tab. Yes, 6 is degrees of freedom. How many rows are there? 1, 2, 3, 4. 4 minus 1. How many columns are there? 3. 3 minus 1. 3 into 2 is 6. R minus 1 into C minus 1. Number of rows minus 1 multiplied by number of columns minus 1. And this is the expected table. See, in Python, you get the expected table. And what is the formula for expected table? Row total multiplied by column total divided by grand total. So you'll get in Python the expected table also. Row total multiplied by column total divided by grand total. So this is the actual table. This is the expected table created using the formula row total multiplied by column total divided by grand total. Right? So last one, test null, no association between outlet underscore size and outlet underscore location underscore type. The input is always cross tabulation. PD dot cross tab. The point. So you are rejecting the null. So chi2 underscore contingency PD dot cross tab Sigma train dot outlet size comma Sigma train dot outlet location type 0. 0 is the output. Now in HR analytics, you can also do this. The two chi-square tests are this. Test null, no association between is underscore promoted and gender. Test null, no association between education and recruitment underscore channel. Okay, these are the tests for HR analytics. For HR analytics, you can do this test. 2 T-tests, 2 ANOVA, 2 chi-square tests for your practice.